Bismillahirrahmanirrahim. Dear students, some of you had asked this question end of the chapter 2.23. So this is an average problem. So I will just show you the solution of this problem here. So this is the solution here. So what they have asked? Oh, sorry, I did not show you. I did not show you the actual numerical. This is the actual numerical. In the circuit shown in this figure 2.87, determine Vx, the power absorbed by the 12 ohm resistors. So what they have asked us to do is that we have to find out this Vx and we have to find out the power absorbed in this 12 ohm resistance. And for finding out the power, you must find the voltage across this resistor, and we also must find the current through this resistor, so that we can find out the power that is given by V is equal to P is equal to Vi. So this is the question. This is a very simple question, not much, but it's a bit lengthy. You see, you have to just reduce the circuit to its equivalent form, and then you have to keep the track of the resistance for which you already have merged them into a series or parallel combination. Then you have to find out the voltage across them. So for this, you will have to just go and solve the circuit for the equivalent resistance, then find out the main current, and then you will have to go back to the intermediate circuits and then find out and then apply the CDR and VDR to find out the voltages and the current. So that's exactly what I have done in this solution of mine, and I will just show you and go through walk you through the solutions, but the thing is, again, I will just insist and urge upon you that this is not the way of watching these videos lectures, because these things are very involved, and it includes a lot of fine details. So if you just sit back and watch the video, so you will not going to get much out of it, because the thing is that you have to practice the things on your own by your own. So watching videos, and that is just like too much of input and then no output. If you are not solving the problem with your own hand, then there is no output. So too much of input is also not a good thing. That will not make you any better in the understanding of the contents and in the skill of yourself for solving the problems. You will not develop that just by watching. You actually have to do it. In the same way that you just can't drive a car. You just can't learn to drive a car just by sitting in the passenger seat for last maybe for 20 years. The same way you cannot learn swimming unless you don't do it. So this applies to many things in the world, and the same thing applies in this course also, that you have to solve the numericals on your own. At least you must attempt the assignment and then submit it. I already have extended the date. So this is the solution. This is the solution, and this is exactly the problem which is mentioned in your work. So these are the values mentioned of the resistance and capacitance. So what I have done is I will just reduce the combinations to its equivalent form. I beg your pardon, zoom level is perfect, or I can just still zoom more for those of you who are watching these videos on mobile phones. So this level of zoom is definitely going to help you. So I just am scrolling it down slowly, gradually. These are the two resistors that can be merged in parallel combination. That's what I have done there, and these are also the parallel combination of the resistors. These will also be merged into one resistor. So you see that this resistance has also been included in the combination. So this is a series with the parallel combination of 3 and 6. That's what I have written here. That is 3 in parallel with 6, and that is being added with the series combination of 4 ohms resistance. So this will become all in all 4 plus the formula for the parallel capacitor, that is the resistance multiplied divided by the addition of the resistance, and this formula applies only to the two resistors. Alright, so 4 plus this is 4 plus 2 and 6, and 12 in parallel with 8 becomes 4.8. So moving forward from this point on, you can add this 1.2 resistance into this 4.8. So that will make it a 6 ohms resistance. Right, moving further, I'll just name few currents of these as I4 and I5, just to trace back the circuit for finding out the required variables, that is Vx and the power dissipated on the rightmost resistor of 12 ohms. You just see that then the original circuit diagram of the problem. Alright, so this resistor comes in parallel with this resistors. So this 6 and in parallel with 6 is 3 ohms. And what point is this? This point I4 is the point through which after 1 ohm resistance, this is the point for I4. This is point for I5. So you can just now find out I4 by applying a CDR. I4 is given by CDR. So this is 3 ohms resistance and this is 1 ohm resistance, so that becomes 4 ohms resistance here and 2 ohms resistance here. So you can easily find out I4 by CDR, and that's what I have done, exactly the same. I have found out the I4. I guess what I have done is here, this is for finding I4. For finding I4 we use CDR, and then applying the CDR here, the 20 is the amount of the current in the current source, and multiply by the value of the resistance 2 divided by the addition of these two. So this comes out to 6.67, and this is the current I4. I4, where is the I4 here in this circuit? I4 is this circuit here at this point, because this is 1 ohm resistance, I have just given it a name of I4. So I4 is already found out. That means that this I4 is being divided between this branch and the rest of the branch. So we can just find out I5 here. So Vx, because we already have found I4 and that is the current through Vx, so we can find out the value of Vx here. So Vx is the current, that is, this is current I4 multiplied by the value of the resistance, that is 1, multiplied by 6.67. This is the answer. Vx is already found out. Now we have to trace back the circuit so that we can find out the current through this resistor of 12 ohms, and we can also find out the voltage across these resistance, because what we have to find out is the power, and power is the multiplication of current and the voltages. That means that we have to find it both. So I hope that I'm clear enough in my speaking, and I'm just giving the right details. So I5 is this thing. So this I4 is being divided into two branches of 1.2 ohm resistance and 6 ohm resistance. So we just find out I5, that is 1.2 resistance, that I5 is equal to I4 multiplied with the 6 ohms resistance, that is this of 6 ohm resistance is this, because whenever you apply CDR and you want to find out current through some particular branch, then the resistance value you use in CDR formula is the other resistors, not that exactly that resistor through which you want to find out the current. So that's why we have just used 6 ohms resistor to find out the current at this point, right? So it comes out to be I5 is equal to this 3.335, and then moving further on, I5 is dividing between 12 ohm resistance and 8 ohm resistance. If you see the problem in your book, so this is the I5, and this is being divided between two branches. But what current we have to find out? We have to find out the current through this resistance, so that we can find out the power. Power is given by, if you have the current, then this is called 12I square. Resistance value multiplied with the current value. So moving further from this point on, we find out the current through the resistance. We have used this I5 here. I5 value is given here, and this we have used the other resistor than the resistor through which we want to find out the current. So we have used 8 ohm resistance here, and it comes out to be 1.334, and I square R is the formula for finding out the power. So that means 1.334 multiplied by 1.334, that becomes power of 2, and then using the value of this 12 ohm resistance, so it comes out to be this 21.335 watt. So I hope this was helpful for you, and this we already have covered 10 minutes around, so we will just keep it toward this, and then in next videos I will be just starting chapter number 3. So till then, fi amanillah, assalamu alaikum.